So why am I harping so much on this business of how thread blocks get allocated to SMs and what guarantees you have or don't have about when they're going to run or where they're going to run? The reason is really that concurrency and ordering are tricky. These are often the hardest things to get right about writing a parallel program, and to teach yourself to think parallel, you really need to be aware of concurrency and ordering, and these notions should be sort of second nature to you. I'm also making this point because if you've done any parallel programming on CPUs, modern multi-core CPUs today, then you have a certain way of thinking about parallelism. And actually the CPU and the GPU are very different in this regard, and so it's worth emphasizing this difference. So a modern multi-core CPU with 4 or 8 cores will have 8 or 16 concurrent threads. On a CUDA GPU, we're often launching millions of threads. For example, in the image processing assignments that you're working on in this class, if you deal with a megapixel image, you launch 1 million threads. And it's important to note that not all of those threads are concurrent. You can't assume that these threads can talk to each other. Some of these will run to completion and exit and not be around for another thread to talk to. So the ability to communicate and cooperate between threads is something you really need to pay attention to on GPUs. So if you're used to doing parallel programming on a CPU, it's important to remember that it's not the same as doing parallel programming on a GPU. You're really operating in different regimes here.